Hi everyone, how are you guys? All good? Okay. So guys, today we are discussing our topic BGP, right? So today is our third class of BGP, right? Yes. Okay. Let's start. Okay. Before start, I am presenting my screen. I hope it's visible to all of you. So guys, today is our third class of BGP. Okay. Okay. Let's continue. Guys, here I written one note. What is this? Interior Gateway Protocol. It means that is IGP, either OSPF or EIGRP. Okay, require direct neighborship relationship, meaning the device must be directly connected. But in case of BGP, that is not mandatory. What is the meaning of this point? Guys, try to understand. For example, this is R1, okay, and this is, let's suppose, R2. Let's suppose here I am running any IGP protocol like OSPF or EIGRP. Okay, let's suppose here I configure 12.1 and here I configure 12.2. Both router will become neighbor. Both router will become neighbor when only and only when both devices are directly connected with each other. In case of IGP. So again, I am telling, in case of IGP protocol, two router two router only become neighbor when both router is directly connected with each other. If both router are indirectly connected with each other, in this case, both router never become the neighbor in case of IGP protocol like EIGRP or OSPF. But in case of BGP, but in case of BGP support direct neighborship as well as indirect neighborship. In case of BGP support direct neighborship as well as indirect neighborship. Okay. Now, what do you mean by indirect neighborship here? Guys, see here. For example, let's suppose we have one, two, three routers are there. So here between R1 and R2, we can establish a neighborship. Between R1 and R2, we can establish a neighborship. Getting my point? That is called direct neighborship. That is called direct neighborship. So BGP support direct neighborship as well as your IGP protocol also supporting direct neighborship. There is no problem. But in case of BGP, you can establish a neighborship between R1 and R3. You can establish a neighborship between R1 and R3. That is called indirect neighborship. Why? Because R1 and R3 is not directly connected with each other. Both are indirectly connected with each other, guys. So that's the reason I am telling BGP support direct as well as indirect neighborship. Clear? I hope you guys understand. For example, let's suppose we have a case number one, R1, R2. For example, here I configure 12.1, here I configure 12.2. Here I configure 12.1 and here I configure 12.2. Yes, between 12.1 and 12.2, we can establish a neighborship that is called direct neighborship. That is called direct neighborship. And in case of BGP, we can perform this type of neighborship. There is no problem. Now, case number two, guys. For example, again, we have a only two router. Now let's suppose on R1 I have one loop back 1.1.1.1. On R2 we have a loop back 2.2.2.2. Yes, we can establish a neighborship between both loop back. We can establish a neighborship between both loop back. That is also called indirect neighborship because both are not directly connected, guys. Both are indirectly connected with each other. So that is called indirect neighborship. Okay. And the third scenario is, guys, case number three. If we have a scenario like this, if we have a three router, then we can establish a neighborship between R1 and R3. There is no problem. That is called indirect neighborship. I hope you guys understand what is direct neighborship and what is indirect neighborship. Your IGP protocol support only direct neighborship. It means two router always become neighbor when both router is directly connected with each other. Okay, but in case of BGP, that is not mandatory. Your device will directly connected with each other. No, that is not mandatory. In case of BGP, we can configure direct neighborship as well as indirect neighborship. Clear, everyone? Now, the point number two, guys. In case of BGP, there is no concept of multicast address, but in case of IGP, like OSPF or EIGRP, we have a concept of multicast address, right? I told you previously, in case of BGP, in case of BGP, every messages is unicast. Every messages of BGP is unicast. Getting my point? So in case of BGP, there is no concept of multicast address. Clear? For example, guys, if you guys remember, in case of OSPF, in case of OSPF use two at multicast address. You guys remember 224.0.0.5 and 224.0.0.0.6. So these are the multicast address which is used by OSPF. Getting my point? Similarly, EIGRP also use 224.0.0.10. So guys, these are the multicast address. Basically, your IGP protocol like OSPF and EIGRP is using to exchange the packets. To exchange the packet. Getting my point? But in case of BGP, every messages of BGP is unicast. Every messages of BGP is unicast. Getting my point? Everyone understand? Okay. Now, BGP support only static neighborship. It means you must manually configure the neighborship. You must manually configure the neighborship. Guys, this is very important. Try to understand what I am trying to say. For example, everyone please focus. This is R1. This is R2. For example, here we have a OSPF. Here I am using OSPF, any IGP protocol. For example, here we have a IP address 12.1. Here I have a IP address 12.2. Clear? Everyone. Now, let's suppose here I configured OSPF 100 and here I configured OSPF 200. After that, I write the command network command. You know the network command. By the help of network command, what we can do in OSPF? Who can tell me? Guys, by the help of network command, we can do three things. Basically, there are mainly three uses of network command in OSPF. First is to advertise the network. Very good. Second one is define area. Very good. Third one is, guys, third one is when you basically run the network command and when you advertise any network, what router will do? Router will check that prefix is configured on which interface, and after that router will convert or make that interface is the part of multicast group. Multicast group. For example, on R1, I run the network command, and by the help of network command, if I am advertising 12th network, then by default, what router will do? Router will check 12th network is connected on which interface. So router will find 12 network is connected on this interface. Now what router will do? Router will make this interface is the part of multicast group. Multicast group. Then when this interface will become the part of multicast group, then on this interface, router can send or receive any multicast packet. If your router or if any interface will not become the multicast group member, then through this interface, router cannot send or receive the multicast packet by default. But when I configure the OSPF, when I write the network command, then after your this interface will become the part of multicast group. It means through fast Ethernet 0 by 0, R1 can send the multicast packet as well as receive the multicast packet. There is no problem. Getting my point? So I told you there are three uses of network command in OSPF. First is to advertise the network in OSPF, to define the area, and third one is to make the interface in a multicast group member. Clear, everyone? Okay. Now, guys, when I run all the command on R1 as well as on R2, I run only two command on R1. First I write, guys, router OSPF 100. After that I write network command on R1. Getting my point? What R1 and R2 will do? R1 send the hello packet. Yes or no, everyone? These things we already discussed in the IGP, guys. R2 also send the hello. In hello, what will be the source IP address? Interface IP address, that is 12.1. What will be the destination IP address? I told you OSPF use multicast address, that is 224.0.0.5. Fine, this is the destination IP address and this is the multicast IP address, right? And R2 will only accept this packet when you configure the OSPF on R2. If you do not configure the OSPF on R2 and if you do not run the network command, then this interface will not be a part of multicast group by default. Getting my point? After running the network command, this interface will become the part of multicast group. Then after R2 will receive that packet, otherwise no. R1 continuously send the hello packet, but R2 never accept it. Why? Because on R2 still you do not enable the services. Getting my point? So see, on R1 and on R2, we already configure the OSPF. R1 is sending the hello packet, R2 is sending the hello packet. Getting my point? Source IP address is 12.1 and destination is 224.0.0.5. Similarly, in case of R2, source IP address will be 12.2 and destination will be 224.0.0.5. Fine. And what is the use of hello packet? I told you in case of OSPF, hello packet contain what? Neighborship parameters. Hello packet contain, guys, neighborship parameter. There are multiple neighborship parameter in OSPF. Okay. So R1 send the hello packet, R2 send the hello packet. Fine. And both router exchange the parameter with each other. Both router already exchange the neighborship parameter with each other. Getting my point? Now, both router check the parameter. If both router agree on that parameter, then both router R1 and R2 will become neighbor dynamically, or you can say automatically. I write only two command on R1 and R2. I write router OSPF 100 and after that I write the network command to define the or to advertise the network in OSPF, or to define the area and to make a particular interface is the part of multicast group. Only two command. Fine. And both router become neighbor dynamically, automatically. Getting my point? So that is called dynamic neighborship. So that's the reason why I am telling this one. In case of IGP protocol, either you can run OSPF or either you can run EIGRP. Either you can run OSPF or either you can run EIGRP. In case of IGP protocol, both router will become neighbor dynamically. On router, I am not going to tell, hey bro, R2 is your neighbor. On R2, I am not going to configure R1 is your neighbor. No, never. In case of IGP protocol, everything will happen dynamically. Both router exchange the neighborship parameter. Both router agree on that parameter. Then after both router will become the neighbor. If both router do not agree on the neighborship parameter, if neighborship parameter will not match, both router never become the neighbor. Getting my point? Understand? But in case of BGP, see, R1, R2. Fine. Let's suppose, guys, here I run router BGP 100. Let's suppose here I run router BGP 200. So guys, on R1 I am running BGP 100. On router number 2 I am running BGP 200. It means on R1 as well as on R2, both router is in the same AS or different AS. Yes, exactly. Both router is in the different AS. So if both router is in the different AS, it means this is the condition of eBGP neighborship, not IGP neighborship. Clear everyone? I hope these things clear. Okay. Now here I run IP address 12.1 and 12.2. Let's suppose we have one loopback here 1.1.1.1 and here 2.2.2.2. Clear? Understand? Now on R1 I am running command. Please focus guys. Router BGP 100. Okay, I run this command on R1. After that I run which command? Network command. What I am running guys? Network command. Okay, guys, what is the use of network command in IGP? Yes, to advertise the prefixes. To advertise the prefixes. Yes or no? Yes. Similarly, in case of BGP, by the help of network command, what we will do? We will advertise any particular prefixes in BGP. Okay. So guys, here I am running second command, network. Let's suppose I am advertising this prefix in BGP. 1.1.1.1. After that, I have to write mask. What is the subnet mask? Let's suppose slash 32. 225.255.255.255. So guys, I run only two command here on R1. Similarly, same command I will run on R2. Only one change. Here I will configure router BGP 200. After that, I write network command 2.2.2.2.2 and mask then slash 32. Okay, everyone. I hope you guys understand till now. Okay. So guys, these are the two command I configure on R1 and R2. But what is the problem in BGP? When you check the neighborship between R1 and R2, neighborship will not up. Even there is no TCP connection. What is TCP connection and why both router configure the TCP connection? We will discuss it later. But right now I'm just telling, if you configure these two command on R1 and R2, both router never become neighbor. But in case of IGP, yaad karo, in case of IGP, what happened? I run only these two command, but both router automatically, dynamically, both router will become the neighbor after exchanging all the parameter. But in case of BGP neighbor, it means I told you in case of BGP support static neighborship. I told you na BGP support only static neighborship. It means on R1 you have to configure and you have to tell R1 R2 is your neighbor, and on R2 you have to tell R1 is your neighbor, and these things you have to tell manually. But in case of IGP protocol, I'm not going to tell manually. But in case of BGP, you have to tell these things manually. Getting my point? So that is the meaning of static neighborship. Clear, everyone? Okay. If you want, I can prove you. Okay, see here. For example, guys, I have two router number 6 and router number 7. Okay. Let me take the console. Yes. On router number 6, let me check the IP address is configured or not. See, 12.1 is configured and one loopback is configured. There is no problem. Okay, everyone. Let me capture this link. Okay. Now, come on R6. Let me ping 12.0.0.2. Yes, I am able to ping. It means IP address is configured on R7. There is no problem. Okay. Now I am configuring guys here right now one IGP protocol. IGP protocol. Let's suppose router OSPF 100. Okay. So I run the router OSPF 100. After that, I have to run only one command, network command. What is this? Network. After that, I have to advertise any prefixes in OSPF. For example, I am advertising 12.0.0.0. After that, I have to write the wildcard mask. Wildcard mask. So I already configured 12.1 slash 8. It means subnet mask is slash 8. Then what is the wildcard mask for slash 8? Who can tell me? 0.255.255.255. After that, you have to define the area. Let's suppose area is 0. I did these things on R6. So guys, right now on R6, I write only two commands. First one is the network command and one is router OSPF 100. Now come on R7. Router OSPF 200. I am writing network command 12.0.0.0.0.255.255.255. Area is 0. Area is 0. Getting my point, everyone? So IP OSPF neighbor. See, both router will become the neighbor. There is no problem. Both router become the neighbor. See na, and I can show you the packet. See here. See, router number 1, 12.1 share one OSPF hello packet. Yes or no? Everyone. Yes na. Router 1 share one hello packet. See, in hello packet. In hello packet, these are the neighborship parameter. Similarly, R2, similarly, R2 send the hello packet. R2 send the hello packet. What is the source IP address? 12.1 and destination IP address is 224.0.0.5. That is the multicast IP address. Fine. So see now what I am trying to show you here. Here on R6, I configure the OSPF 100. After that, I write the network command. On R7, I write OSPF 200. After that, I write the network command. I write only these two commands. R6, share the hello. R7, share the hello. Both are multicast. Both router exchange the neighborship parameter and dynamically both router will become the neighbor. There is no problem. Getting my point? Yes or no? Yes, fine. But in case of BGP, it will not happen. In case of BGP, it will not happen. I can show you. I can show you. See here. Let me stop the capturing here. Let me remove the OSPF from R7 as well as from R6. Yes. Now, again, I am capturing this link. Guys, I just tell you one thing here. I will tell you in detail way, but right now I'm just telling you one thing. In case of IGP protocol, we have a hello packet. We have a hello packet, and by the help of hello packet, generally router exchange the neighborship parameter, right? But in case of BGP, we have a which packet? Open packet. What is the name? Open message. Okay, we will discuss these things in a detailed way, but right now for your information, I'm just telling you we in BGP we have a open message. Okay, now come on R6. See here guys, what I am doing on R6, I am writing command router BGP 100. Done. After that, I am writing the network command. I told you, na, by the help of network command, we can advertise the prefix in BGP. Okay, let's suppose I am advertising 1.1.1 in BGP. What is the command? Network. After that, tell me 1.1.1.1. After that, mask. What is the mask? /32. Here you need to write subnet mask. But in case of IGP, we are writing wildcard mask. Right na? 255.255.255.255. These things. Getting my point? Everyone. Tell me yes or no. See here. So IP protocol. See. BGP 100 is configured. There is no problem. Maximum path is 1. No problem. Okay. This is what? This is the AD value. This is the AD value. I told you, na, there are two type of AD value in BGP, 20 and 200. Right? If any router receive any prefixes from its IBGP neighbor, BGP neighbor, then what will be the AD value? 200. But when a router receive any prefixes from any eBGP neighbor, so in this case, what will be the AD value? 20. Clear? I hope you guys understand. Now, see, I already configure guys router BGP 100. After that, I advertise the 1.1.1.1 network. Okay, guys, one more thing. Tell me, in case of OSPF, whenever whatever you are advertising, that prefixes will be present in which table? Database table. In which table, guys? Database table. Similarly, in case of EIGRP, if you guys remember, I told you that prefixes will present in which table? Topology table. Yes or no? Yes. Similarly, in case of BGP, whatever you are advertising, BGP store that prefixes in BGP table. Which table? BGP table. What is the command to check? So IP BGP. See, I advertise na this one. So see, 1.1.1.1. Next stop is 0. What is next stop? 0.0.0.0. What do you mean by 0.0.0? It means 1.1.1.1 is self-advertised. It means on R6. R6 is advertising this prefix. So that the reason next stop is this one. Are you getting my point? Everyone understand what? Yes or no? Yes. See, so I run on R6 only two command. What is router BGP 100? After that, I write the network command to advertise 1.1.1.1. Same command I am going to write on R7. Router BGP 200. After that, I am writing the network command, and here I am advertising 2.2.2.2.2. Okay, mask will be 255.255.255.255. See the BGP table. So IP BGP, yes, it is present in the BGP table. There is no problem. But what is the problem? When I check the neighborship between R6 and R7, how can I check? So IP BGP summary. I am not getting any result. I am writing the command so IP BGP summary command to check the neighborship. To check the neighborship, I am writing the command so IP BGP summary. I am not getting any result. It means what? There is no neighborship between R6 and R7 right now. See, I have one more command. So IP BGP neighbor. See, I'm not getting any result here. It means there is no neighborship between R6 and R7 right now. Are you getting my point? It means, what is the conclusion here? Conclusion is I already configure router BGP 100 or 200. After that, I write the network command. Same thing I did on IGP protocol, but their neighborship dynamically established. But in case of BGP, nothing is happening here dynamically. It means I told you, in case of BGP, if you want to establish a neighborship, you have to configure manually. You have to configure manually. Now please focus here how, even I told you na, in case of BGP, router exchange the which message? Open message. Router exchange the open message to exchange the parameters. Yes or no? See na, do you guys find any open messages here? No, we are not getting any open message. Even you guys are not able to see any BGP message. Yes or no? Yes. Why? Because if the neighborship is not established, then how router will exchange any messages? No, router never exchange any messages until neighborship is not established. Okay, now please focus, how can we configure the neighborship manually? Come on, router number 6. Router BGP 100. We are running here router BGP 100. Okay, after that you have to write the command neighbor. After that, you have to write the command neighbor. After that, after writing neighbor, you have to write the IP address of the neighbor. IP address of the neighbor. Here I want to establish a neighborship between 12.1 and 12.2. That is direct neighborship. Yes or no, everyone? Here I am going to establish a neighborship between 12.1 and 12.2, and both are directly connected with each other. That is called direct neighborship. Okay, even I can configure the neighborship between 1.1.1.1 and 2.2.2.2. That is called indirect neighborship. We will discuss indirect neighborship later, but right now we are only discussing the direct neighborship. Okay, everyone. Now see, I am writing neighbor. After that, you have to write the IP address of neighbor 12.0.0.2. Done. After that, what? Are tell me. After that, you have to write the command remote AS. After that, you have to write remote AS. It means now you have to write the AS number of your neighbor. AS number of your neighbor. So guys, who who is your neighbor? I want 12.2 will become the neighbor of R6. I want 12.2 will become the neighbor of R6. Fine. On R 12.2 is configured on R7. Yes or no? Yes. And on R7, what is the AS number you guys are using? AS number 200. So here you have to write AS 200. So that is the command to establish a static neighborship between two routers. Same command I have to run on R7. See here, conf t. Here we are running router BGP 200. After that, neighbor. I want to establish a neighbor here between with 12.1, 12.0.0.1. After that, I have to write remote AS. What is the AS number on R6? 100. 100. See, now check the neighborship. See here, neighbor 12.2 is now up. Even you can check. So IP BGP summary. Now we are getting the result. Now we are getting the result. What is the result? Who is the neighbor? 12.2 is the neighbor. What is this? This is the version of BGP. Generally, we are using version number 4. What is this? AS number 200. It means my neighbor. Who is neighbor? 12.2 is neighbor. And what is the AS number of my neighbor? 200. Getting my point? That is, it means total five messages we received from the neighbor and total five messages we sent. Getting my point? What do you mean by up and down? It means till 10 second our neighborship is up. Getting my point? Are tell me yes or no? Yes. Now, what is this? State. What is state? State is here blank. There is nothing. If there is nothing, it means established. Please remember, if there is nothing, it means established. It means our neighborship between 12.1 and 12.2 is established. Are you getting my point? Yes or no? Yes, na? Now, what is this? Prefix received. Prefix received. It means we received one prefix from my neighbor, that is 12.2. We receive one prefix from my neighbor, that is from 12.2. Why? Guys, if you guys remember, I already run network command. Yes or no? Yes, na? We already run now on R1 and now at R2. Network command we already configured. Yes or no? Yes. So what is the use of network command? By the help of network command, generally we are advertising the network in BGP. Yes or no? Yes. So see, on R1, on R6, you run network command, and by the help of network command you advertise 1.1.1.1. On R7 you run the network command for 2.2.2.2. It means R7 is advertising or sharing this prefix with R6, and R6 is sharing this prefix with R7. So that's the reason in a result you are getting prefix 1. Are tell me, that's the reason you are getting prefix 1. Why? Because R6 receive one prefix from its neighbor, that is 2.2.2.2.2. So IP BGP. See, in BGP table there is 2.2.2.2.2. Are you getting my point, everyone? Yes or no? Yes, na? Arey, that is that BGP table of R6. R6 receive 2.2.2.2 from 12.2. From 12.2. Getting my point? I told you now, whenever BGP receive any prefix information, either whenever you are advertising any prefix in BGP, or router receive any prefix from any neighbor, router store that prefix in which table? BGP table. So that's the reason both prefixes are present in the BGP table. One is which is advertised by router itself. Array, which is advertised by router itself. That's the reason next stop is 0.0.0.0. So that this is 1.1.1 is the prefix which is advertised by R6 itself. And what do you mean by 2.2.2? And this is the prefix R6 received from its neighbor 12.2. Are you getting my point? Yes or no? Yes, na? Same command if you run on R7, you guys will find 1.1.1.1. See, so IP BGP. See, R6 is R6 is advertising which one? 1.1.1.1. Why? 12.1. So R7 is getting 1.1.1. Why? 12.1. Why? Because on R6 you already advertise 1.1.1.1 in BGP. Yes or no? Yes. Clear? I hope you guys understand till now. Clear? So IP BGP neighbor. This is the command. If you want in a detailed way, you can run this command. Here you guys will find the complete detail information. If you want, you guys can write this command. See, who is the neighbor? 12.2 is the neighbor. What is the AS number of my neighbor? 200. This is external link. What do you mean by external link here? Here you will find either external or either internal. Internal, when you find internal, when on R1 as well as on R2 AS number is same, it means IBGP neighbor. In case of IBGP neighbor, you guys will find here internal link. But here on R6 we configured AS number 100. On R7 we configured AS number 200. So it means both are EBGP neighbor. That's the reason here is link is external. Link is external. Getting my point, everyone? Yes or no? Yes, na? So, and what is the VGP version? I told you VGP version 4 we are using. And what is the router ID of my neighbor? That is 2.2.2.2. Guys, router ID is same as IBGP. In case of IGP, you know, na, in case of OSPF, what is the conditions for the router ID? Same thing in case of BGP also. So what is the by default router ID here? 2.2.2.2 here. This is the router ID of my neighbor. Are you getting my point? Yes or no? Yes, na? So what is the BGP states? I told you established. What is the states? Established. And this is the time. So it means from this time our neighborship is established. Are you getting my point, everyone? So if you want to see the neighborship condition in a detailed way, this is the command you guys can run. Getting my point, everyone? Anyone who do not understand anything? Very good. So what is the conclusion in case of IBGP? Sorry, in case of IGP protocol or in case of OSPF, we do not need to run the neighborship command manually. Both router become neighbor automatically by exchanging of hello messages. But in case of BGP, in case of BGP, you have to write manually. What is the command? Please remember. What is the command? Are tell me. First of all, you have to write router BGP. Let's suppose on R6 we are running 100. After that, you have to write neighbor. Who is the neighbor? 12.0.0.2. After that, you have to write remote AS. Remote AS means you have to write here AS number of your neighbor. So 12, who is the neighbor? 12.2 is my neighbor. And what is the AS number on 12.2? That is 200. So you have to write this one. So this is the command. So please don't forget this command. Are you getting my point, everyone? Yes or no? Yes? Okay, cool. Now, move to the next point, guys. Okay, these things we covered. Now, BGP must establish a TCP connection between the peer using TCP port number 179. So please remember, BGP use TCP port number 179. BGP use, first of all, remember this one, BGP works at layer number 7. Yes or no? Do you guys remember RIP? RIP is the protocol which is also works at layer number 7. But at layer number 4, it use UDP. But in case of BGP, it use what? TCP. And I hope you guys know what UDP versus TCP. UDP is not reliable, but TCP is complete reliable. You know, not reliable. Reliable means for every messages, you guys will get the acknowledgement. That is called reliable. But in case of UDP, you guys will not get the acknowledgement. So that's the reason UDP is fast compared to the TCP. Yes or no? Yes. Now, BGP use T TCP at layer number 4. At layer number 4, are BGP use at layer number 4 what? TCP. Okay. And what is the port number? 179. 179. Are you getting my point? Yes or no? Yes. Now, what is the point? BGP must establish a TCP connection between the peer or neighbor using the port number 179. Initially, BGP established the TCP connection before sending any BGP message. There are multiple type of BGP messages. We will discuss these things in a later. There are multiple type of BGP messages. For example, open message. For example, keep alive message. For example, update message. For example, notification message. For example, root refresh message. There are multiple type of messages in BGP. But please remember, first of, let's suppose this is the R1 and this is the R2. When you configure the BGP, when you configure the BGP, first of all, both router establish a TCP connection. Please remember this line. First of all, both router establish a TCP connection. Then after, both router will exchange any messages like open message, keep alive message, update message, any messages. Getting my point? So that's the reason I am telling you this is the very important thing. In case of BGP, both router establish a TCP connection first of all, then after both router exchange any BGP messages. Okay, and what is the port number? 179. Fine. Now, I written one more point here about the TCB. TCB stands for Transmission Control Block. TCB stands for Transmission Control Block. What do you mean by TCB? See, na, a router maintain a transmission control block or TCP table to store the information about the TCP connection. Guys, this is the router and this is the router. Let's suppose both router establish a TCP connection. So where both router store the information about the TCP connection? Guys, this router store na, this router must know na ki I am establishing a TCP connection with this router on this interface, and the IP address of this interface is 12.2. There are multiple things. Getting my point? So there is a one table called TCB. What is the table, guys? TCB. So TCB is the table where generally router store the information about TCP connection. How can you check? There is a command, show TCP brief. This is the command. By the help of this command, you can check the TCP connection or TCP information. Getting my point? Everyone understand? Now, this is very, very important. What do you mean by this? See here, everyone. R1, R2, 12.1, 12.2. Are you getting my point? Yes or no? Yes, na? Okay. On R1, I write router BGP 100. After that, I write network sorry, not network, first of all, neighbor, because we have to write the neighborship command manually, right? Now, in case of BGP, neighbor 12.2 remote AS 200. Are you getting my point? I run how many command? Two command here. Come on R2. On R2, I am running router BGP 200. After that, I am running neighbor. Who is the neighbor? 12.1. 12.1 remote AS. What is the AS number on R1? 100. Here 200. So on R1 I write this command. On R2 I write this command. Now what will happen? Anyone? See the things what will happen, guys. I configure the BGP here, okay? And I already told you, there are multiple types of messages in BGP, like open message, keep alive message, update message, many messages. But I told you, before sending any types of BGP message, both router establish a TCP connection. Both router establish a TCP connection. I hope you guys already know about TCP connection. Generally, how TCP connection will establish. If you guys don't know, I am telling you here, please understand very, very carefully. Let's suppose on R1, I configure this one. On R2, I configure this one. Let's suppose R1 is initiating the TCP connection. So R1 send one TCP packet. R1 send one TCP packet. Are you getting my point? Understand? Now, in TCP packet, I told you many times, in TCP there is multiple type of flag. Getting my point? In TCP packet, R1 enable one flag that is called SYN flag. R1 enable one flag that is SYN flag, synchronization flag. Okay? And R1 send this TCP packet towards R2. Towards R2. Are you getting my point? Everyone. What will be the source IP address? 12.1. What will be the destination IP address? 12.2. Are you getting my point? Everyone. Understand? I told you earlier, in case of BGP, every messages will be unicast. So there is no concept of multicast or broadcast. Okay. So R1 is sending the TCP packet. In TCP packet, what is SYN flag bit is on. Okay. Now this packet receive on R2. What R2 will do? R2 again send one TCP packet. In this TCP packet, R2 is enabling two flag. First of all, R2 is sending the acknowledgement of this SYN. So it means acknowledgement bit will be 1. So it means R2 is enabling the acknowledgement bit in its TCP packet and sending towards R1. So here, what do you mean by acknowledgement? R2 is sending the acknowledgement of R1 SYN. Fine. And in the same TCP packet, R2 enable SYN bit for on router. It means here in this TCP packet, R2 is telling two things. R2 is telling the acknowledgement of this SYN, and R2 is sending its own SYN. Its own SYN message. This packet will reach on R1. Again, R1 send one more TCP packet, and in this TCP packet, R1 is sending the acknowledgement of R2 SYN. So in this case, R1 enable the acknowledgement bit and share towards the R2. Fine. Understand everyone. Anyone who do not understand? Okay, very good. So guys, here, if you guys observe one thing, between R1 and R2 to establish a TCP connection, both router exchange how many messages? Total 3 messages. How many messages, guys? Total 3 messages. R1 is sending the TCP. In TCP, SYN bit is on. R2 is sending the TCP. In TCP, SYN is on as well as ACK is on. And again, R1 is sending one more TCP. And in this TCP, again, acknowledgement bit is on. So R1 and R2 both are exchanging total 3 messages. So that's the reason the establishment between, the between TCP connection between R1 and R2, and the process is known as three-way handshake. And this process is known as three-way handshake. By this way, both router 1 and router number 2 establish a TCP connection. Getting my point? If anyone asks you now, what do you mean by three-way handshake? I hope you guys is able to answer. Three-way handshake means three-way handshake is the process by which both routers establish a TCP connection to exchange the TCP packet. In first TCP packet, router enable the SYN bit. Second router will again send the TCP packet, or in this TCP packet, second router is sending its own SYN message or acknowledgement of first SYN, and again R1 will send one TCP packet, and in this TCP packet, R1 is sending the acknowledgement of R2 SYN. Getting my point? That is called three-way handshake. Clear, everyone? Now, there is one more point. Please read this line. The device initiating the TCP connection use random source port number. Random source port number, while the destination device use the BGP port number. What do you mean by it? Everyone try to focus here. R1, R2. You know, first of all, both R1 and R2 wants to establish a TCP connection. Yes or no? Yes. Okay. Before sending any messages, R1 and R2 want to establish a TCP connection. R1 is sending the TCP packet. In this TCP packet, I told you, SYN bit is on. Fine. R2 is sending the TCP packet, and here SYN plus ACK both are on. Yes or no? Yes. Again, R1 is sending which packet? TCP packet, and in this TCP packet, acknowledgement bit is on. Yes or no? Yes. Now, if both router is exchanging the TCP packet, it means you know na TCP packet works at which layer? Layer number 4. Yes or no? Yes. If you guys remember, we already discussed about the TCP header. Yes or no? Yes. In TCP header, there are two fields: source port number, destination port number. Yes or no? Yes. Now, here I am written the point. The device who is initiating the TCP packet use any random source port number. Use any random source port number. Getting my point? So let's suppose R1 is initiating a TCP packet. Let's suppose R1 is using one port number, random port number 4096. Are you getting my point? That is the source port number. But what will be the destination port number? Destination port number will be 179. Are you getting my point? It means R1 use always a random port number. Let's suppose 4096. But for R1, who is the destination? R2 is the destination. R2 always use BGP port number, that is 179. I hope you guys understand these things. Again, I am telling the device who initiate the TCP connection, that device always use any random port number. But the device, the receiver device or destination device always use the BGP port number, that is 179. That is 179. Getting my point, everyone? Anyone who have any doubt? No? Okay. If you guys don't have doubt, guys, tell me one thing. I told you this is the R1 and this is the R2. Let's suppose R1 is sending the TCP packet. So definitely R1 use any random port number. Yes or no? I told you na these things. Okay. Now the question is, how R1 will decide any random port number? How router will decide any random port number? Any idea? No. See here. For example, this is the R1, this is the R2. For example, R1 is, let's suppose on R1 we configure the BGP, on R2 we configure the BGP. I'm telling you from the scratch, okay? So on R1, on R2, we configure the BGP. Yes or no? Yes. So when you configure the BGP, definitely it is wants to establish a TCP connection. Yes or no? Yes. So between both device, one device will initiate and other device will receive. Yes or no? Yes. Okay. So the device which initiate the TCP connection use a random port number, and your destination device use the TCP port number, that is 179. Yes or no? Yes. Now, the first point you have to remember, generally in random port number, generally device use the random port number. What is the range? 49152 and 65,535. Generally you will find router use the random port number between, so this is the range to use the random port number. Getting my point, everyone? Now one more thing. Basically, in case of bgp in case of BGP, generally router use one technique. Generally, router use one technique. What is the name of that technique, guys? PRNG. What is this PRNG? PRNG is the technique. Now again, you guys will ask the full form of PRNG. What is the full form of PRNG? Who can tell me? P means pseudo random, pseudo random number, or G means generator. Yes, pseudo random number generator. Okay na? So basically what is PRNG? PRNG is the method. Okay, so basically router use which method? PRNG method. Okay na? So basically PRNG is the method. What PRNG will do? PRNG will choose any one unique source port number, any source port number, and generally PRNG choose the unpredictable number. Unpredictable number. Getting my point? And definitely it reduce the chances of conflict in terms of port. Are you getting my point? But again, this is not a algorithm. This is not a algorithm. Are you getting my point? What I'm trying to say? Yes, the router is using the process or method. The name of that method is PRNG. What is the name of PRNG? PRNG means pseudo random number generator. So router use this method to generate one random port number. But again, PRNG use one algorithm, guys. PRNG also use one algorithm. What is the name of that algorithm? LCG. What is the name? LCG. LCG stands for linear, C for I think congruential. You can check on the Google, congruential, and G for generator. Getting my point? So LCG what? LCG is the algorithm. And who use LCG algorithm? PRNG. PRNG is the method who use LCG algorithm, and generally LCG use any complex mathematical formula to calculate the port number. Getting my point? So this is the things I know which I already share with you. Getting my point? So this is not the interview type questions, but yes, if you want, you guys can remember this one. Again, I am telling the device who initiate the TCP connection, that device use the random port number. What will be the range? 491522 65,535. So generally this is the range for the random port number. Okay, and device choose the random port number by the help of one method, that is called PRNG method. And PRNG use one algorithm, that is LCG algorithm. And LCG algorithm use any complex mathematical formula to calculate the random port number. Okay, cool. Okay, now once TCP connection established, then after router exchange the other types of messages like open message, keep alive message, any other message. Getting my point, everyone? Okay, now I will show you how TCP connection established. What is TC B table I will show you. See here. So I remove the BGP from R6 or R7. Okay. There is no routing protocol now. Okay. Now let's capture the link. I am on R6. Okay. What is the command? Router BGP 100. Okay. After that, I have to write the command, guys. Network. Sorry, not network. Neighbor. What is the neighbor? 12.0.0.2 and remote AS will be, guys, 200. Are tell me yes or no? Yes, na? This is the command for the static neighborship. Now come on R7 router. One more thing, guys. On R6 I configure the BGP router BGP 100 and I configure the static neighborship command. But on R7 I do not configure BGP. What is happening here? Anyone who can tell me? No? Okay. I'm telling you something. Please read this one. Who can read? See, R1 with BGP configured. On R1, let's suppose we have R1, we have R2. On R1, we configure the BGP as well as I write the neighbor command. But on R2, I do not configure the BGP. This is the scenario I am telling you. Okay, na? So I am asking you what will happen. See here, R1 with BGP configured, send the, I told you, when you configure the BGP or when you write the neighbor command, immediately R1 starts sending which packet? TCP packet. And in this TCP packet, R1 is enabling which flag bit? SYN flag bit. Yes or no? Yes. R1 is sending the SYN packet to initiate the TCP connection on port number 179. It is initiating. It means it will use any random port number. But what will be the destination? Destination port number will be 179. It means this device use the port number this one. Yes or no? R2 without BGP configured. It means on R2 BGP is not configured. Receive the SYN packet. But on R2 BGP is not configured. BGP is not configured. So guys, when this packet will reach, so what will be the destination port number? 179. So this router received the packet. When this router open this packet at layer number 4, this device will check what is the destination port number 179. But see na, on R2, you do not configure the BGP. You do not configure the BGP. So if you do not configure the BGP, it means 179 belongs to BGP and BGP services is not enabled on R2. Destination port number is 179 and 179 belongs to BGP at layer number 4 and on R2 BGP services is not enabled. So if the required services is not enabled, then what will happen? By default, your TCP send which R2 send the TCP packet, but here R2 send which flag? Reset flag. R2 enable which flag, guys? Reset flag. It means TCP connection is not established. Are you getting my point? Yes or no? Yes, na? I will show you here. Don't worry. See here. Come on here. See, who is sending R1? R1 is sending the packet. What is? Sin bit is on here. Yes or no? Are tell me. Sin bit is on, na? Everyone. Yes or no? Okay. See. What is the source port number? I told you, na? The device who is initiating the packet, that device use any random port number. So that is the source port number. Destination port number is BGP port number, that is 179. Yes or no? Are yes or no? Yes, na? Now, I told you in TCP packet there are multiple type of flag. See, let me open this flag. See here. In this flag, you guys will find SYN bit is on. Rest all are off. Only SYN bit is on. Yes or no? Who is sending? R1 is sending this TCP packet, but R2 is also sending the TCP packet. R2 is also sending. Let me open one. Sorry. Let me open one TCP. Who is sending? Yes. Source is this one. See now, what is the source port number? 179. Source port number is 179. Destination port number is any random port number. Yes or no? Tell me yes or no. Yes. But when you check the flag, when you check the flag, in this flag, you guys will find the reset flag is on. It means TCP connection is by default. So by the help of reset flag, we will understand definitely the required services is not enabled on R2. That's the reason R2 is sending the reset flag. Yes or no? Yes. Now, come on R7. Router BGP 200. I am writing neighbor. Who is the neighbor? 12.0.0.1. I am writing here remote AS. What is the AS number on R6? 100. Are tell me yes or no? Yes, na? So this is the way how we configure the BGP. Are understand? Yes or no? Yes, na? I told you the TCP connection. Yes or no? I can prove you the TCP connection. See, everyone please see very carefully. See, this is the who is sending the TCP connection, guys. TCP packet 2. Okay, I am opening this one. Source port number is random port number. Destination port number will be BGP. Yes, na, I told you. And see, what is the SYN bit is on here. Okay, now who is sending? Uh, where is? Yes, this one. And here, see na, what is the flag bit on? SYN. Are tell me SYN as well as acknowledgement. Both flag bit is now on, and the third one is acknowledgement. Third one is only acknowledgement. I told you na everyone, yes or no? Yes na. So actually what will happen? R1, R2. Let's suppose if R1 is initiating, it initiate the TCP, and in TCP SYN bit will be on. Fine. R2 send the TCP, in TCP SYN plus ACK both will be on. And third, it generate the acknowledgement, sorry, TCP packet, in TCP acknowledgement bit will be on. So actually this is the process happened. Okay, everyone. Now let me check TCP connection is established or not. What is the command? So TCP brief. See, I told you now about the TCB. See, this is the TCB. And so this is the TCB table. And here in this table, generally router store the information about the TCP connection. Are you getting my point, everyone? Here router store the information about TCP connection. Are you getting my point? What is local address? Local address means this is the R6 R7. On R6, what is the IP address? 12.1. And R6 is using which port number? BGP port number 179. It means here R7 is initiating the TCP packet. So that's the reason port number is 179. For R6, who is the neighbor? Foreign address is 12.2. It means 12.2 is neighbor. And 12.2 is using the random port number, that is 22,463. And what is the state? State is established. What is the state, guys? State is established. Getting my point, everyone? Yes or no? Yes, na? So basically this is the way how we can configure the BGP. So till now what we will discuss? So till now we discuss how we configure the BGP, how we configure the static neighborship on the BGP, how router establish a TCP connection, what is TCB? Are yes or no? Yes, na? How basically router exchange the TCP packet or like SYN acknowledgement? Yes or no? What is when router generate the reset flag bit? So these things we discussed today. Yes or no? I hope you guys understand these things. So this is enough for today. In fourth class, we will discuss the more thing about the types of messages in BGP. There are multiple types of messages in BGP. We will discuss in the next class. Okay. Thank you very much, guys.